So I'm going to do more videos about logarithmic functions and get into the whole idea of graphing them. But for now, I just want to focus on that domain issue, right? Let's just talk quickly about a separate example. When we were back in the radical section, right, we looked at something like this and said, what's the domain? What am I allowed to plug in? And since we weren't allowed to plug any negatives inside of our square root, we knew that whatever was in here had to be greater than or equal to 0, since it's okay to take the square root of 0. So 0 is okay, we can have an equal to, but it has to be positive. So we could figure out, like for this question, x has to be greater than or equal to -3. And if you made a table in your calculator, what that table would look like is you'd have your -3 would pop out 0, and then at -4 you would see error, because at -4 things started going to heck, right? Things started not working out so well. So we had the same issue here with our logarithms. And remember, when we did this with radicals, anything happening outside the radical didn't matter. Only thing that matters is the inside. I could put a coefficient out in front. I could add, subtract 7 from there. I could divide the whole thing by 8. None of that matters. The only piece that matters is that we don't take the square root of a negative number. So the domain of this would still be x is greater than or equal to -3, or looking like this, right? -3 with a hard bracket up to infinity. So our logs have similar issues. If we're taking log base 2 of x, what we just said on the last page is there's no way, and let me actually write this with f of x out in front. We'll use our function notation. There's no way to take this thing, and if you had this as a y, right, because f of x is just a fancy way to write y, and rewrote it, there's no way that we can take 2 to a power and get out a 0 or a negative, because 2 is a positive number. So if you multiply it by itself, it's always going to be positive. And it's not 0, so when you multiply by itself, it can never be 0. So with that in mind, whenever you have a logarithm question, you have a very similar thing to do as we did with the radicals. You're going to look at your argument, the inside of the logarithm, and you're going to say, okay, that has to be greater than 0. It has to be positive, right? It can't equal 0. In the radical section, we could equal 0 because square root of 0 is fine. Here, we cannot equal 0. So if you actually looked at the table in your calculator for this function, you'd see this. 0 is error, 1 is 0, 2 is 1, and you see your whole table, but your error actually starts at that sort of limitation, and your domain is 0 to infinity. So if I make this more difficult, you're going to do the exact same idea, right? I guess I'll put that back so you guys have it if you want it. We can't equal the 0, so it's 0 to infinity. So here's an example. Find the domain, possible x values of f of x is equal to log base 5 of x minus 7. So I want you guys to try that one out on your own. So just like the radical, we care about the argument. We know that that argument must be greater than 0. It has to be positive in order for this to work. So we get x has to be greater than 7, which means we're going from 7 to infinity, not including the 7 because we have the strict greater than. And you could look at the table in your calculator. Again, you're going to see the same thing. At 7, you have an error, and at 8, you have 0, right? So this is going to keep happening. All right. And again, just like with this other one, it doesn't matter what has happening outside. I can add a 4. I could plus 3 on the out. None of this matters. The only piece that matters is, can I evaluate the logarithm?